So in this video today, we're going to measure angles and radians. Our objective is that you can learn to switch between degrees and radians and for both sector area and arc length, okay? So this is our warm-up, and this is what we learned yesterday, was how to find sector area and arc length, okay? So I'd like you to pause the video here, go ahead and find the answers to these two problems, and then come back to me when you're done. And these formulas, by the way, are on the formula sheet. So this is area. So we're going to say area is equal to pi r squared m over 360, okay? So what is that? This is our radius, right? And this is our m. So we're just going to plug those into the formula. So area is equal to pi times 19 squared times 315 over 360. Okay, so go ahead and do that in your calculator. 19 squared, if you haven't already, times, and put in parentheses 315 divided by 360. So I got area is equal to pi times, I got 315.875. So obviously 21 divided by 2 is not 315. 49 divided by 6 is not 315. And 55 divided by 3 is not 315. So let's go ahead and do 2527 divided by 8. And guess what we get? 315.85. So I say compare all these answers right here by putting them in a calculator and determining which one is the answer you got. Okay? So this other one, again, we have... This is our m here, which is 45, right? And then we have our r right there. That's our r. So this is length is equal to 2 times pi times 16. And then we're going to do 45 over 360. So this time you can multiply everything across there just like that. 2 times pi times 16 times, in parentheses, 45 over 360. Okay? I know my handwriting's not very clear there, y'all, but I think you guys get it. And so when you do that one, you should have got 12.6. Okay? And remember, because it says rounded to the nearest tenth, we're actually going to multiply by that pi. So we're going to talk about radians and degrees today, converting from degrees to radians and from radians to degrees, okay? So a radian is a unit of measure for angles. 1 radian is the angle made at the center of the circle by an arc whose length is equal to the radius of the circle. So basically, to convert from degrees to radians, you're just going to divide whatever the angle measure. Remember, theta always means angle. Okay, that's what it means, okay? When it has theta, it means you're going to take the angle, the degrees, and divide it by 180 and add on to it pi radian. So it's a simple process, y'all. So we're going to take our 30 degrees, we're going to divide it by 180, put that in your calculator. Again, most of y'all can see that 30 divided by 180 is going to be 1/6, right? No, wait, 30, 18/6, yes. Sorry, my brain's a little tired. So yeah, this is going to be 1/6, right? So, and then so that's going to be equal to 1 over 6 pi. So we can say pi over 6, right? And these are radians. Okay, we're going to do another one. So here we go. 75 divided by 180. That's how you get it. And when we do that, we get 5 over 12. Again, I think most of y'all know that 5 times 15 is... So again, we're going to add pi to the top, and this is our radians, okay? So again, if you're looking at answer choices, just figure out what fraction they both give you, okay? So let's see if you guys can do these two. So this one says negative 36 divided by 180. Go ahead and do that. So this one's going to be negative 1 over 10. So that's going to be negative pi over 10, again, radians. Okay, do the next one. Be another you try, y'all. So go ahead and do that one. 270 divided by 180 is equal to, you got 1.5, which you should all know is 3 over 2, so it's 3 pi over 2, again, radians. Okay? And again, if you get a decimal at TI-84, you can just push math 1 and it'll turn that fraction into decimals. So this one's a little easier. So we're going to replace the pi with 180 and multiply or divide. So basically, if it's in radians and it's pi radians you're dividing by, then obviously the radians cancel each other out, right? And so will the pi's, okay? So what we're going to do is every time we have a pi over 4, we're going to replace it with a 180. So this is going to be 180 divided by 4. And when you divide 180 by 4, you get 45 degrees, right? This one to me is easier than going the other way because you don't have to worry about that fraction, okay? So, example 2b, I guess I skipped. So I'm going to do it here. So example 2b, was 2 pi over 9. 2 pi over 9. Okay, so what are we going to do? Again, we're going to multiply 2 times 180, divide that by 9. So that's going to be 360 divided by 9, which is, guess what, 40 degrees, okay? All right, so to check it out, let's see if you guys can do these two. Again, just change that pi to 180. Pause the video here. Go ahead and do it. 5 times 180 divided by 6, 150 degrees, right? Okay. This one's minus. It stays minus. So this is going to be 3 times 180 divided by 4. And that's negative 135 degrees. Okay, so then this next part says if the central angle theta defining the arc is given in radians, then the arc length can be found by using the formula. So basically, this shows you why the arc length. So if we cancel out the 2 pi and the 2 pi, what are we left with? Just theta times the radius, right? And theta is equal to, it's just in radians, okay? So all we have to do here is do 7 pi over 6 times r, right? Which is, in this case, and it's asking us to find the arc length given in the angle in radians, okay? So this is going to be arc length, right? So what does that mean? This is circumference, yes? So, okay, so we're going to multiply that by 9. So, again, you can give the answer in radians or in degrees. So this would be 63 over 6, right? 63 over 6. So this would be reduced to be 21 over 2 pi radians, right? Or if we multiply that out, then that's going to give us our approximate answer, right? Okay, so that's going to be 32.99, and these are yards, okay, both. Okay, so go ahead and do this one. All you're doing is the radius times our theta, and then we're going to do that as an exact measure and as an approximation. So you're just doing what? Pi times 2, right? And that's feet. And then just multiply 2 times pi, and I think that's 6.28, right? Feet. Okay, so that's our equal, and that's our approximate. All right, for the next one, it says area of a sector. Okay, so when we're talking about the area of a sector, again, notice here that pi cancels out, and 1, so you're left with theta. And you could do this like this. You could do r squared times theta divided by 2, right? Either one of those is the same thing, okay? So what we're going to do is we're going to do 9 squared times 5 pi over 6. And then whatever we get for this, we're going to divide by 2, okay? Now remember, we're going to leave pi in our first answer, okay? We're going to leave pi in our first answer. So do 9 squared. And times 5 divided by 6, and then divide all that by 2, okay? So when you do that, you should have got 33.75 pi, and this time it's millimeters squared, right? Because this is area, okay? And then we're going to multiply that 33 by pi. So our approximate answer is going to be 106.03, again, millimeters squared, okay? So here's our last one. See if you guys can do it. So we're taking our radius, squaring it, and then we're multiplying that by pi over 2, right? And then we're going to divide all that by 2. So remember, you're going to leave pi in your answer to begin with, right? So leave that pi there. So isn't that 36 divided by 2, which is 18, and 18 divided by 2, I'm pretty sure is 9, right? So this is 9 pi, again, miles squared. Okay, then we're going to multiply that by pi, so that's going to be 28.27 miles squared, okay? Okay, so there's some extension problems at the bottom of the page, and those are if you want to challenge yourself, so go ahead and attempt them if you want, or you can just pause here and go ahead and start working on Delta Math, okay? So I'm going to figure out what theta is. This is a sector of the circle has a central angle of pi over 4. So this is equal to our theta right there. And then it says an area of 4 pi over 8. I'm sorry, 48 pi over 8. So this is our area, okay? So that means we're going to do 48 pi over 8 is equal to 1/2 r squared times pi over 4. That's our formula, right? So let's see, what do we get here? So if we just multiply across here, we're going to get r squared is equal to pi over 8, times pi over 8, right? And that's going to be equal to 48 pi over 8. Now let's see if we can multiply by the reciprocal here. So that's going to be 8 over pi here, and that's going to be 8 over pi here. Well, that works out nice because the pi cancels out the pi and the 8 cancels out the 8. So 48 is equal to r squared, so then we just take the square root of both sides. So r is equal to 6.93 centimeters, right? Okay, so the next one says the sector of a circle has a radius of 4/3 centimeters, an area of, find the central angle. Okay, so we have a radius of 4/7. We have an area of 8 pi over 49. So we're using the same formula we did before, right? So what we're looking for is the central angle in radians, right? So that's going to be our theta. So that means we're going to put our area over here. 8 pi over 49 is equal to 1/2 of 4/7 squared times our theta. We're looking for theta, right? So 4/7 squared is going to be 16 over 49. 1/2 of that. So half of 16 would be 8, right? So this is equal to still our 8 pi over 49. Let me give myself a little more room to work. So if I divide that 16 by, y'all notice if I could just make that 2 times 49, or I could just divide the 16 by 2, okay? So, but I'm just going to divide the 16 by 2. So this is 8 pi over 49 is equal to 8 over 49 times theta. So we're just going to multiply both sides by its reciprocal. 49 over 8. 49 over 8. I know this is hard. Again, you don't have to do it. This is an extension, so this is just to try to see if you can figure it out. 49 cancel out 49, 8 cancel out 8, so we got pi is equal to theta, and so guess what? That means that this angle is 180 degrees, huh? Because pi equals 180.